Let me begin by saying that I deem it an honor and distinct privilege to stand before you for the inauguration of this very important and aptly titled National Conference, Climate Resilience and Sustainable Development. So my all experience and contribution in this area is very, very limited to the use of space-based observations. I'll come to that slightly later. Let me also, I had the chance to look into a document which we released, the proceedings. It has 10 expert talks and more than 55 research contributions by the youngsters who are sitting here. So I will like to bring to your attention some cross-cutting and common issues while you are touching on some specific areas. One is like development we understand and climate we understand, right? Metaphorically, climate is just average of weather over 30 years as per that. So now why the climate should have so many prefix and suffix? Change, resilience, that is very important. As Professor Ramakrishna pointed out, climate has been changing and will continue to change. So what has changed in this change is the natural evolution, and the Earth's balance is altered by human activities. And we have accelerated this change. That is what the IPC says. There is now unambiguous evidence. So much so that whatever you have read your geological era, now many scientists say the current era should be called Anthropocene. Anthropocene means it is all controlled by human activities. Why human activities should be able to control such a large, Earth which is so complicated? Generally, the balance between the physical system, chemical system and biological system is maintained. But then we have done a couple of things. One is the carbon dioxide, what has been talked of, right? The carbon cycle is truly composed of two cycles. A geologic cycle which runs into millions of years, and a very fast cycle which has the half-life of between 7 to 12 years, which is the biosphere to atmosphere and the absorption. In fact, we forget many times that it is the disruption of the geological carbon cycle which is the mining of the fossil fuel and its release at a very rapid rate, which currently is of the order of 7 petagram. Peta is 10 raised to power 15 gram carbon, which actually creates the largest thing. And it was Arrhenius in 1905 who showed if the CO2 were to increase in the atmosphere, the outgoing infrared waves will be absorbed, and it will lead to heating of the lower atmosphere, cooling of the upper atmosphere, and warming of the Earth. So after living through all this exercise, 3 more things have happened. One is the deforestation and land use change, which basically not only releases some amount of carbon but changes the albedo. And what this albedo, brighter albedo, means is more radiation actually is getting reflected. Also, the water which was locally cycled due to forests, if you remove the forest, that all water leads to only runoff and soil erosion, which is another problem. Third is a very simple process called Haber and Bosch. So what the entire natural nitrogen fixation does, our factories, right? Our factories reduce more nitrogen than the entire global nitrogen fixation, which basically people would like to sort of look at it and come back with various strategies. But there is always a flip side. What the youngsters have to understand, why are we here and what happened then, is just not to be understand only one side. We are able to feed the entire population only because of this nitrogen fertilizer. Otherwise, crop productivities would not have risen. If you look at the data between 1880 and 1930, population growth was very, very less. 3 factors: wars, famine, right? Plus, there was not enough protection, in the sense the communities were not from slavery to whatnot. There were various social structures which are there. So the post-Second World War, what we have tried to look at is develop. Now, development is itself a very loaded word. Everybody looks at development from his starting point to what his aspirations are. So, for everybody, the development is different. And in a world which is so unequal, right? And there are so many disadvantaged communities, so there are 1,000, or I would say billion development goals. So why this resilience and sustainable comes? Let me point out that the IPCC 6th assessment report, it defines climatic resilience as, resilience is defined as a capacity of social, economic, and ecosystems to cope with hazardous events or trends or disturbances and respond or reorganize in ways that maintain their essential function, identity, structure, biodiversity, while maintaining the capacity for adaptation, learning, and transformation. A lot of words have gone into this IPCC definition. I just want you to reflect on one. I believe we are mostly here science and technology. That is obvious because this is a KSTA program. But most interestingly, on the dais, we have a banker, or let us call economist, although by training he may represent the science and technology. The definition clearly says the resilience is also social and economic. So the first thing which I would suggest to all youngsters is to talk to your social science, economics, sociology, humanities friend and learn their tools, their language, and how social systems and societies and economies evolve. Because scientists sometimes tend to feel development of a method itself is the development of human being, which never happens. Second, resilience in a climatic context is a very useful concept, because resilience encompasses socially inclusive and transformative, which was there in the definition. So, which means the ability of all to mitigate vulnerability. Resilience will not come till the vulnerability is mitigated, and there are more vulnerable people, there are more vulnerable infrastructure, right? Vulnerability itself varies across the scale. So what it means is resilience is used as a socially inclusive concept, transformative, mitigating vulnerability, and you adapt to what? Climatic hazards, variability. Why this is useful? One, it is across the sectors. So we are not talking of urban area or agriculture or rural. We are not biased towards it. So resilience means every sector, all encompassing, development. Second is, it is also open to interpretation. So resilience itself can have many definitions. So what I hope you will see is many people will present resilience and development from a very, very narrow point. Understand that point and assimilate with your own discipline to convert it into a larger concept. That is my suggestion. But in contrast to resilience, the sustainability has been in much, much longer use. Around 1950s, the first conference on human activities and earth happened. By 1972, we really were talking of the sustainable development, right? And there were very, very famous reports from Brundtland Commission to the small is beautiful. But the sustainability is there in scientific, technological, economic, social and political discourse. Sustainability is not pure only science. Science sustainability may mean enough water or rainfall available for crop, or the soil to have that nutrient over multiple generations of planting, or the forest to recover after a fire or any such disturbance. But the sustainability is even a larger concept than. So once you hyphenate sustainability with development, and development, as we said, has a billion perspective, you really end up into a very, very complicated world. The good point about this complicated world is that we are committed. That is why we are here, to see a better world, to make a better world, right? That is why we are here. So the current phase, globally, let us say, Professor Ramakrishna already mentioned, so I won't repeat those 17 SDG, National Sustainable Development Goal. But let me tell you, in June this year, the United Nations, the SDG Secretariat, it released its report called June 2023 Status. And they found almost every parameter, across the nation, we are lagging behind. We are just halfway through and just 7 years to reach that place. So unless we really pull up the socks, we won't reach there. So when this report was presented, Antonio Guterres, the Secretary General, said, unless we act now, the 2030 agenda will become an epitaph for a world that might have been. Right? So just there are concerns that even similar to the Millennium Development Goals of 2015, similar to Kyoto Protocols, similar to what was the Paris Agreement, even SDG, we will miss the bus. Okay? This is a very, very... So they have proposed many things. I will just read out amongst the 5 key points. One of the key points, the government should advance concrete, integrated, targeted policies and actions to eradicate poverty, reduce inequality, and end the war on nature, with a focus on advancing the rights of women, girls, and empowering the most vulnerable. This actually summarizes where we are lacking maximum globally. I will not go more except to say that report also says that there is a large gap and we really need to work on climate resilience. Why the gap is there? Either the resources are not there, people don't have access to technologies. Those issues, I think, are all there. We will come to it. Let us for a moment shift to India. Generally, let us say about 80% of the districts, there are climate-induced disasters, rising temperature, changing rainfall pattern, declining groundwater, retreating glaciers, intense cyclones, sea level rise, right? So what all these things do? One, they create a crisis of livelihood, they create a crisis of food security, and they also create a crisis of economy. The people who suffer, actually, they also lose sometimes their source of income. So they really go down the poverty and take a lot of time to come back. And in the urban areas, this can be even more intense because you have more people concentrated, and there are large pockets of urban areas which don't really have the facilities which are generally associated with urban. So this is, you can have in, let us say, which we call squatter settlements, you can have intense disease, very risk of exposed to heat waves, and a large number of other, even floods, etc. Their whole house can get washed away. It is estimated in the last decade, the number of extreme events have doubled. I think that's why if you just look at the newspaper, and it is likely that this increase will continue. Generally, if you remember your statistical normal distribution curve, right? So the climate change is not that the bell-shaped curve has slightly shifted to warmer. Actually, the climate change is that the bell-shaped curve, the size of the bell at the bottom has become very large. So both sides of extreme is more likely to occur. This is in addition to the air quality issue I think Dr. Ganesh Raj was talking about. So what do we need? How do we really build climate resilient world? Lot of activities were there. I think Professor Ramakrishna, so I will not cover the national mission, I'll skip them, but let us talk some of the projects. So one of the aim of climate resilience is to lower the carbon footprint. How do you lower the carbon footprint, right? Like one way is to have a odd and even numbers on the road like Delhi wanted to do for pollution. The other is to, people say, please do carpooling, but for the infrastructure and development, what we require are greener modes of transport, like let us say Bangalore Metro. A metro will replace, so many automobiles. The national dedicated freight corridor, east and west freight corridor, use of waterways, right? The Waterways Authority of India and waterways to do. So like one train can replace more than 100 trucks. So if you really have trains continuously running for transporting all from our, Amazon and what we order, vis-a-vis the food and other petrol which gets transferred, we need to do. Secondly, we need to reduce fossil consumption and emission through improved logistics. But more importantly, I think we also need to develop a sustainable transport system. That is a public transport system. This human-oriented car, well, good, we will shift from our, the first we had petrol cars, then we thought because of policy diesel is cheaper, then we started purchasing diesel car, so that policy was an issue. Now we are buying hybrid cars, slowly we will buy more electric cars, and we will find that there is no lithium on the battery, then we will replace the lithium by another material. Even that material will be mined, and then what we will do? We will have technologies, people say, we will mine moon, we will mine asteroid, right? So somewhere this has to stop. Most important part is restoring the dwindling forest cover. Forests do a lot of ecosystem services. They have biodiversity, they actually maintain the water cycle, right? They have so many organisms. Don't use forest only to take out wood. Of course, poor people also depend it for firewood. That is another area. Now, promoting resilient agriculture is very much there, but the issue with the resilient agriculture is you have so many variants, right? You will have zero tillage, you have organic agriculture, you would have other type of thing. But then, if you really want to feed that many people, would that much productivity be sustained? There is not enough evidence. So it can't be single objective based. Also now there is a talk of having climate smart agriculture. I saw a paper also, one of the authors is contributing. So there the idea is, how do you maximally and most intelligently use the climate to your benefit. I'll just give you one example how it can work in the reverse way. In the north, because mention was made, you have first rice, right? And when you take rice and the basmati, because the price of basmati is so high, and even government said, okay, you can export. Basically, when you export basmati, you are exporting your minerals and water, right? But farmers, for them, it is their income and livelihood. Then the wheat season starts, and in between the time is so less that the farmer finds it economic to burn. If he was to water and plow, the duration and the wheat sowing will be delayed. Actually, so he is actually adapted. He's a smart person, but he's actually creating pollution in Delhi, because Delhi is like a plate, a bowl, and when this transition from this autumn to winter happens, there are no winds. So what happens, this pollution settles over this entire northwest, and in the day the boundary layer comes up, it goes up, and in the night it again comes down. It doesn't go anywhere for 15 days. It just stays there. So what is the policy? We were once discussing the policy could be instead of summer vacation, have vacation. Because what COVID showed us was, if you stop all the transport, stop movement of people, air quality improves. I don't know. You have to think of what should be the policy action. I'll come to it. The other is, we have in India one of the largest, after the irrigated area, also the dams. There are 5,700 dams, huge dams. In fact, dams store water, they also produce electricity, and they also irrigate crop and allow the agriculture to happen. Now, dams were constructed with a particular design, with particular water flow, and dams have collapsed also in recent years. So is this infrastructure climate resilient? We may have to really look and re-engineer the strength of our dam. Other is the groundwater. We are pumping out groundwater at such a rate that water which actually takes thousands of years to infiltrate 700 to 900 feet, right? The infiltration rate per year of the order of centimeters per year. Not the upper purse groundwater, the really deep water. And when we take it out, in fact, more than 1 feet per year is the depletion in Northwest. Then urban. In addition to urban, let us talk of coastal first. A huge number of population lives in the coast. And what the tsunami did to the districts which were exposed and had less mangrove. So the mangrove and shelter belt and really building the resilience of the coastal communities is another issue, making the flood prone areas safe. We are having a lot of fascination of the solar power, but the point is solar power, all the PVCs are actually coming from China, and they have a life, and then we need water to clean them. Also they are occupying now, let us say the largest one occupied almost like 2,800 hectares, right? So it actually is, at the moment it is land, so it almost like so many square kilometers. There is a smart way which people thought, the big Narmada canal, so on the canal water they put also the thing. Now this solar power supply is out of phase with this energy electricity demand, which happens in night. So how do you store this excess solar power, right? If you do battery, you have an issue. If you use it pump to take the water up, then you have a recovery issue. So you please learn these technologies. And now we talk of green hydrogen. Hydrogen plants actually the mitochondria and chlorophyll are the best, most efficient biological system as they have evolved over billions of years. What exactly they do is they use a membrane and a small electron to transfer proton on one side and electron on one side. And then they use this catalytic thing which has a very, very small delta energy. But whatever way we will produce, we will consume lot of energy to really extract hydrogen. India has now recently approved 7,500 crore hydrogen, national hydrogen mission, right? We also have made lot of things on entire development, I think economy development. We also need to safeguard future health. So the COVID showed to us one virus, the diameter is only 90 nanometer, the COVID, and it brought the entire world to standstill. So we need to, this climate resilience and the health, we really need to work on it. I will touch upon this space, why space comes, and I hope perhaps that is the reason. We have looking at through the gravity measure, if the gravity goes down, static gravity, you can actually measure the water withdrawal over large area. You actually can see the poles and the increase and decrease in the snow extent. You can mount lidars and check whether at the polar the ice sheet is thinning. You can really have a hyperspectral sensor and see whether in the north and the south pole the ozone hole size is increasing or decreasing. Incidentally, the only success which the human society had was the Montreal Protocol of banning the ozone depleting substances. Other than that, very, very few things have done. We do forest cover monitoring, right? We do agricultural, mapping soil moisture. And in all, in fact, the satellites allow us better weather prediction and better cyclone warning. Weather prediction allows agriculture and all us to move, and cyclone warning prevents deaths. You may not know because you are younger, the Odisha super cyclone killed thousands, 10,000 plus, as late as 1998, 99. And now the similar cyclones have deaths almost like 1 dozen, 2 dozen, that too because of the simple flooding, some people. It is not, scientists should not claim that it is because of the prediction alone. It is because of the government readiness, a government which can shift 800,000 people in 24 hours and then bring them back and keep them away from cyclone for 3 days. So it is actually the governance structure, community action and preparedness which is very, very critical. So as students of future, we are having a seminar. I'm sure you will also have a training program. But I just want to flag 2 issues. How many of you actually have learned the integrated modeling, in the sense not your own one particular area, but having a different system of, let us say, vegetation growth or a soil moisture or an atmosphere model, link it to a societal thing. All these issues what we are talking actually require integrated modeling. They do not require one theme modeling. The flip side of this modeling is models are nothing but a simplification of the word. They only allow us to, mathematically check the interaction. So do not believe that model is the God which gives the correct answer. No. You have to understand model themselves have huge, huge errors. But then, when you do science, I think this was also mentioned, you are able to do science, as the very famous quote is on the science is that if I have looked further, it is standing on the shoulder of giants, right? So science depends upon the previous generation which has handed over this. So I suggest to you, in the modern era of data science, AI, machine learning, whatever you observe, whatever you measure, learn to make it open and share. Unless we rapidly adopt this culture of open science and open sharing, I think we will be doing, again and again trying to do the same thing. And since I mentioned the policies, like MNREGA is a very good policy. It allows people to at least have food guaranteed for 100 days. But it allows the infrastructure, plantation, grassland, so many things that it improves the environment of a very small local place. We need such policies. But the policies have to be data and evidence based. They can't be just based on some off the axis idea. And then it also means you have to bring in social sciences, humanities and economics. I wish you luck. I wish you will learn and develop the appreciation of the complexity involved in this title of climate resilience and sustainable development. More than that, I suggest that you interact with all your friends, especially those who have come from different disciplines. Learn to have this conversation and develop collaboration.